Dear students, in the last module, we had a very informal review of algorithm. And today we will start discussing formally what is an algorithm. So if we formally define an algorithm is an ordered set of unambiguous executable steps that defines a terminating process. So we have 1, 2, 3 and 4 properties of an accurate algorithm. So now we will discuss each of these 4 properties of an algorithm, that how these properties or characteristics are hold. So first of all is ordered set of steps. So first of all we should understand that there is a difference between order and sequence. So sequence means that these are the instructions. So first will be executed first, and then second and third and fourth and so on. But in algorithm we need a structured ordered representation. For example, it doesn't happen in many of the algorithms that they are just following sequence one by one. For example, we have learned flip-flops in one of the previous modules. They are producing their output individually together. So if there are 100 flip-flops, all of producing their own value and they are not depending on one another. So this means we need to define this order, that all of they will get input from here, and then all of them will produce this output, and that output will be understood as a value in the storage system. Similarly, there could be some parallel computing algorithms, parallel processing, in which an algorithm can be divided into different parts and each part is producing its own result, and at the end we are integrating all of the steps. So this means that algorithm is a ordered and structured to establish a structure in terms of order of their execution. The next characteristic is executable. If for example we say a statement, make a list of all positive integers. So making an algorithm for such a problem is not possible, because there are many infinite number of positive integers. So how can we make an algorithm that is not actually executable? So algorithm should be executable. For example, you can say that we want to make a list of all positive integers between 1 and 100. So that is possible. 1 and 1 million, that is possible. 1 and 1 trillion, that is possible. But making a list of all positive numbers, that is not executable. So computer scientists use the term effective to capture the concept of being executable. So if you listen this term effectiveness, algorithm effectiveness, this means that whether the algorithm is executable or not. Then the algorithm should be unambiguous. It should not have multiple meanings. The statement should not have multiple meanings. The information in the state of the process must be sufficient to determine unique and completely the actions required by each step. For example, I say make a pretty cartoon. So what is pretty? I need to explain that pretty cartoon will have such a dimension, it will have 2 eyes, it will have such a face, it will wear such a cloth. So all of these characteristics I need to define, then it will become an algorithm. So this statement is an ambiguous statement. So different people can take different meanings of the same statement. So this is ambiguous. Then there should be a terminating process. So the execution of algorithm must lead to an end. It should not keep on running all the way. But there could be some systems like monitoring the vital signs of hospital patient, maintaining and aircraft altitude in flight. So all of such systems which are like the sensors which are sensing the environment, the patient retrieval or patient management systems, in-flight management systems. So all of these systems are keep on running. But some scientists argue that they reach to their end and then they start. So it is not an unending algorithm. It has reached to its end and then it is going to start, reach to its end and then it is going to start, and so on. So it has a terminating process. So if we summarize today's module, we have formally defined the concept of algorithm and we have learned about 4 characteristics: order versus sequence, executability, unambiguous terms in form of algorithm, and we have also learned that there should be a terminating condition or process for algorithm.